one-sided limits. So this is the notation. This is the limit as x approaches some number, let's say, we'll just say c, from the right of f of x. And this is the limit as x approaches c from the left of f of x. So this is called a one-sided limit. So you're just approaching x from the left or from the right and trying to see what y approaches. So here's a nice example. Let's do the limit as x approaches 0 of the function absolute value of x divided by x. And I'll sketch a graph of that so we can see what it looks like. Okay, so if we were to plug in values, let's say we would plug in 5 into this function, x equals 5, we'd get 5 divided by 5, which equals 1. Okay, we'll call this 1. 5 divided by 5 is 1. If we plugged in 4, we'd get 4 divided by 4 equals 1. 3 divided by 3 equals 1. And you keep getting 1 every single time until you get to 0, because you can't have 0 in the denominator. So that's an open circle. And it goes like this all the way to infinity. So the limit of this function as x approaches, I'll write this out, the limit of f of x as x approaches 0 from the right. So as we come from the right towards 0, you're getting closer and closer to the y value being 1. So the answer is 1. So that's the right-sided limit is 1. If we were to plug in negative numbers, let's say we plugged in negative 5, and we took the absolute value, that would be 5 over negative 5, which is negative 1. If we plugged in negative 4, we'd get 4 over negative 4, which is negative 1. And we keep getting negative 1 as we go towards infinity. As we approach 0, we know we can't plug in 0, but we can get closer and closer to 0. So the limit of f of x as x approaches 0 from the left is equal to negative 1, because as we approach from the left, we constantly get negative 1, and we're getting closer and closer to the y value being negative 1 as we get to 0, but it never actually gets there because it's undefined at 0. Oh, so the answer is negative 1. So the right-handed limit is positive 1. The left-handed limit is negative 1. So when we're asked the question, what is the limit of the function, the overall limit of the function as x approaches 0, the answer is that it does not exist, because the left hand and the right hand are not approaching the same value. In order to have an overall limit as x approaches 0, y has to be approaching some number. And in this case, it's not approaching a number, it's approaching two different numbers, one from the left and one from the right. So when the left-hand limit does not match the right-hand limit, the overall limit does not exist. Okay? Let me see another little sketch. This is helpful. Use another color. If we had a function that looks like this, linear with a hole in it, we would see that as you approach, let's say 1 from the right, you're getting 1 for the y value. If you approach 1 from the left, x approaches 1 from the left, you get 1. So the overall limit here does exist because the left hand matches the right hand. So this is just an example where the overall limit does exist. And that's one-sided limits. Now I want to look at the intermediate value theorem, also known as IVT. So this is called the intermediate value theorem, also known as IVT. And that's if f is a continuous function on a closed interval. Maybe I'll write this out. If f is continuous, and it's important that it be continuous, on a closed interval, we'll call that AB, then this is sort of informal definition. For any y value, there is an associated, or there is at least one x value. So IVT is really simple. What it's saying is that if you have a function on some interval, say from A to B, and you have the function is continuous, so maybe it looks like this from A to B. There's no breaks in the graph from A to B on this closed interval, including A and including B. If it's continuous, then for any random value we choose of y, let's say this value, there has to be an associated x value with that. So this is your y value. If you went over, you can see that there's an x value that's associated with it. Okay, so it's called the intermediate value theorem because it's saying that somewhere in the middle, so somewhere between A and B, if it's continuous and there's no breaks in the graph, then for every y value there's an associated x value. A real life example of this would be like if someone is 5 feet tall this year and next year they're 5'2", then somewhere during the course of that year they must have been 5'1", because growth is continuous. So here's just a brief graph of what I was just saying. If this year, let's say this year 1 and this is next year, if you're in year 1 you're 5 foot, let's just call 5 feet tall, and on year 2 you're 5'2" tall, then somewhere in between you must have been 5'1", because we don't just shoot straight upwards. It's a continuous, growth is continuous. So this is time over time, and this is your height. So if you have a y value that says that you were 5 feet tall, then there must be some associated time value. At some time between that course of that year, you must have been 5'1". And that's the intermediate value theorem. It says that there has to be a number in between those two numbers. Intermediate means somewhere in the middle. If you've ever been to a theater, to a play, then in the middle of the play they take an intermission. So that just means that in the middle you take a break. So intermission or intermediate means in the middle. And this is called an existence theorem. It guarantees that if it's continuous that there must be some value. It doesn't tell you what the value is. You have to determine that on your own. It's just an existence theorem. And here's an application. You can use IVT to show that polynomial function has a zero. So let's just look at this. So use IVT to show that the polynomial function, and I'll write out the function, let's call it f of x equals x to the third plus 2x minus 1, has a zero on the interval 0 to 1. So somewhere on that interval there's a zero, meaning it crosses the x-axis. That's what we mean by a zero, or a I forgot the other word I was looking for. So if we look at this interval and we look at f of 0, say what happens when we plug 0 into this function? If we plug 0 in here, we get 0. We plug 0 in here, we get 0 minus 1 is negative 1. If I plug in f of 1, the other end of this interval, 1 to the third power is 1, plus 2 times 1 is 2, so 1 plus 2 is 3, minus 1 is 2. So if I were just to make a random little graph here, quick graph, I know that polynomial functions are continuous everywhere. There's no break in a polynomial function. And we see that at 0, we're at negative 1. So that's this point here. At 1, we're at 2. which is this point here. So because I know that polynomial functions are continuous, if at 0 I was here below the x-axis, and then at 1 I was at 2, then somehow I must have crossed the x-axis somewhere between 0 and 1. And that's guaranteed by IVT, the intermediate value theorem. Guarantees that I must have crossed. It doesn't tell me what that x value is, but it guarantees that there has to be one, because if you were below the x-axis and now you're above it, then you must have crossed through it, because all polynomial functions are continuous, right? This is a third-degree polynomial, so the graph looks something like this, right? We learned that in pre-cal. So IVT guarantees that there is a value between here and here. It doesn't tell us what that value is. If I wanted to know what that value is, I wanted to know when y is 0, I would have had to set this equal to 0 and then solve this. And that would tell me what that value is where it crosses. But for now, we're just asked to use IVT to show that the polynomial function. And that's an application of the intermediate value theorem.